Alright, welcome to Chapter 8 of your Pre-Calculus 12 course. This chapter involves something that's totally new to, I think, most of you, something called logarithms, but it does have something that is connected to what we just learned in Chapter 7, so I'd like to try to use the material from Chapter 7 to help you introduce this concept of logs. Alright? Also, we'll need to know something called inverse, and I think you remember that from section 1.4. And if you don't, quickly right now, pause the video and look back at your notes first, and then come back and take a look at this investigation. So what I'd like you to do today is plot a graph of the function y equals 2 to the power of x. And once again, this is a lovely example of the exponential function, which is what we learned in Chapter 7. And then afterwards, I want you to graph out the inverse of this function by reflecting the graph in the line y equals to x. And I made a table of values for you, so you can use it if you wish. And if you don't want to, that's perfectly fine as well. Okay? I'll let you try this on your own. So I hope this part's pretty straightforward to you. And if not, then you obviously didn't learn Chapter 7 really well. Go back and review that too. So here's y equals to 2 to the power of x. And remember, inverse is really reflecting it or switching the x and y values around. So I'm going to rewrite this as x equals to 2 to the power of y. And then I'm going to switch the table values. So my x value becomes 1/8, 1/4, 1/2, 1, 2, 4, 8. And my y values become -3, -2, -1, 0, 1, 2, and 3. Okay? I'm going to now use this to graph out my inverse. So 1/8 is at -3, 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, 8, 3. And I'm going to graph this out. Lovely. And this is, I guess, x equals to 2 to the power of y. Now, before we continue, I'd like to look at just some of these characteristics of the exponential and this inverse graph. So the x-intercept for the exponential, well, I don't think there is one, so none. There is a y-intercept, and I think that happens at 1, so we'll put that down. The domain, yeah, we should remember that as all real numbers from last chapter. And the range, yes, it's bigger than 0. With the asymptote, and in this case it's a horizontal asymptote at the value y equals to 0. Okay. Now notice once we've done the inverse, though, what should happen here? Well, the x-intercept seems to be at 1. And there doesn't seem to be a y-intercept. Right? Once again, inverse, switch x and y. Notice that the y-intercept is really the same as the x-intercept of the exponential. Okay. Domain in this case, I think that just means x is bigger than 0. And the range, well, the range seems to be all values of y. And the asymptote in this case is going to be a vertical asymptote. And if you said x equals to 0, you are definitely correct. So, interchanging the x and y variables on y equals to 2 to the power of x, we get this lovely equation, x equals to 2 to the power of y. But most of the times we like to express y in terms of x, not the other way around. So the question is, how can we express y explicitly in terms of x? You know, we've got a problem here since y is in the exponent position and not on what I call the baseline. So how do we bring that exponent down? So in order to express y in terms of x, given that you have x equals to 2 to the power of y, we define y as follows. And we'll write something like this. Y equals, and you'll see log with a small 2. It's a subscript, okay? Small little 2, and then an x. Okay? And this is read as y is the base 2 logarithm, and there's our keyword for today, logarithm of x. Okay, y is the base 2 logarithm of x, or y equals log base 2x. Okay, those are two ways of saying it. Now, what I want you to understand is that these two equations, x equals to 2 to the power y and y equals to log base 2x, or y is the base 2 log of x, they're the same. Okay, they're mathematically identical. They're the same thing. Okay. Now, to generalize then, what I want you to understand is if you have any type of exponential, x equals to c, which is a constant to the power of y, and then you have y equals log base c of x. Okay, so remember, base c log of x. Now, once again, we had those restrictions from the exponential chapter. Note that the c value, the constant, has to be bigger than 0, and it can't be equal to 1. Okay, if you got all these things, then what we have in general for the domain of this log graph is that the domain is always going to be x is bigger than 0, like what you see above. And the range is always going to be all real numbers. And the x-intercept of log base cx is always going to be 1. And the vertical asymptote, in this case it's going to be a vertical asymptote, is always x equal to 0. So these are just some characteristics, okay? And I'll say these are characteristics of the logarithm graph. So y equals to base c log of x. All right? Okay, welcome to logs. Let's turn the page. Note again that if I give you these two equations, x equals 2 to the power of y and y equals to base 2 log of x, they are mathematically identical. Even though they don't look the same, they are mathematically the same. So if I wrote down something like this, 3 equals log base 2x, or sorry, not base 2x, base 2, 8. So once again, 3 equals base 2 log of 8. That means the same thing as, well, let's take a look. Okay, so I'm trying to ask you to match up this part here with this part here. So the base is 2, okay. The x is the 8. That means if I want to rewrite this in the exponential form, it'd be 8 equals to 2 to the power, and y, that looks like it's the 3. So 3 equals to log base 2, 8 means the same thing as 8 equals 2 to the power of 3. So that 3 over here really is the exponent. Okay, so thus a logarithm is really just an exponent. So thus, if I wrote down log base 2, 8, that is the exponent that is needed to write the number 8 as a power of 2. Okay. More generally then, if I have log base 2 of x, okay, not 8, this log base 2x is the exponent necessary to write x as a power of 2. And even more generally, or in general, if I have y equals to log base cx, well, that y, okay, is the exponent necessarily used in order to write x as a power of c. So in other words, and once again, this is in a box, so it's important, okay? If I write down y equals to log base c of x, okay, y being the exponent, well, in the exponential form, we have the equivalent of x equals c to the power of y. Okay, these are equivalent forms. Okay, so the three parts, okay, once again, y, that's the exponent, okay. We've got the base c, and here's base c, and then we have the number, which is x. Well, that's just the number over here. Okay, this is called logarithmic form, that's exponential form, and that's what you need to know for today. Okay, so keep that in mind, memorize, box it. Well, I already boxed it for you. Okay, memorize, understand, it's important. Okay, So now what I'd like us to do is look at some examples, and I want you to just get comfortable with this logarithmic form and this exponential form. So I've got three examples in number one where I've written them as exponents, and all I want you to do is change them into logarithmic form. Okay, so all you need to do is identify the y, the c, and the x, and then rewrite it in logarithmic form. Okay, I think the easiest part is the base, so that's c. So in this case, the base is 6. So I'm going to say log base 6. And then the exponent is y. So that's what the logarithm is. So the exponent's 3. So I'm going to write down 3 equals to then log base 6. And then x is the number, so 216. So if I wrote down log base 6 of 216, that's equivalent to me writing down the number 3, which is equal to the exponent in my power. Okay, you try the next one on your own, please. Identifying the base is always the easiest. Remember, the exponent is what the log is equal to, and then just put the number over there. Okay. Once again, the base is the easiest. The exponent is what the log is equal to, and the last thing is just that number. Okay. All right. Now, if I were to switch it around, let's see if you can go backwards now. Given the logarithmic form, I'd like you to change it to the exponential form. Okay, 2a. Let's do that together. Log base 3 of 81 equals to 4. Okay, once again, base 3, so that's easy. 3 is my base. Look for my exponent. Well, the exponent is what the log whole thing equals to, so that's 4, and then the last number must be 81. Okay, you try the next ones, please. Base, exponent, number. Part C. Base, exponent, number. Okay? You're going to get lots of practice like this. Okay? You're going to need to know how to change from logarithmic to exponential form. It's a must. Alright, well now I'm going to ask you to actually evaluate some of these logs. Remember, each one of these logs represents an exponent. So, my question to you for 3a is base 2 log of 128. What exponent is that equal to? Now, I gave you a hint. I said, evaluate these logs by changing them into exponential form. So I'm going to ask you to just write down x after all these, because you're going to solve this equation. And so now what I'm saying is you've got base 2 log of 128 is equal to x. How do we solve for x? Well, let's change this into exponential form first. So exponential form will be, well, take the base, which is 2, raise it to the exponent, which is the 8, and that's supposed to equal to the number 128. Well, then here's where you have to ask yourself, from last chapter, 128, that's equal to what as an exponent? 2 times 2 times 2 times 2 times 2. Oh, I don't know, man. Let's use the graphing calculator to help us out, maybe. Actually, I do know, but for those of you who don't. 2 to the power 6? Oh, no. 2 to the power 7? Oh, yeah. So this is the same thing as 2 to the power 7. So 2 to the power x equals 2 to the power 7. So what's x equal to? Oh yeah, 7. Okay, the rest are the same. So I want you to try those, please. Go ahead. Now once again, you should be stopping the tape and trying this yourself first and coming back to check. That's how you really learn. Don't just copy me. Okay, I hope you got those answers. You feel good about it? Turn to the next page. Some more tricky ones. Same idea though. Let them all equal x. Same idea. Change them into exponential form. So my base here is 3. So 3 to the power x just equals to that number. Well, that's kind of nice because it's already an exponential form for you. So, hey, x just equals to 5. Wasn't that bad after all. And then e, we've got here, I think, 6 as the base. My exponent's x. And this equals to root 6. Now, once again, how do I write root as an exponent? Yeah, if you remember, that's those fractional exponents, 6 to the power of half. That's cool. And so x equals to 1/2. Remember that stuff, guys? Root 6 is 6 to the half. If I wrote down cube root of 6, that'd be 6 to the 1/3. Remember that kind of stuff? And I wrote down like cube root of 6 all squared. That's just 6 to the power of 2/3. Good old exponential stuff from, I think, grade 10. All right, f. The base is the 4. So 4 to the power of x equals to 1 over the cube root of 8. Oh my. We have to rewrite that as an exponent. Okay. Some of you might be knowing, oh yeah, cube root of 8, that's just 2. Awesome. So this is the same thing as 1/2. Okay, so 4 to the power of x equals to 1/2. Now here's our other dilemma. 4 and 1/2, the bases aren't the same. Uh-oh. We're going to make them the same somehow. So 4.5. Sorry, 4 and the number half. What can we do? Which base can we use? Well, if you're thinking, I know 4 is equal to 2 squared. Yeah, you're right. And then 1/2 equals to 2 to the power of, oh yeah, -1. Yeah, that's good. So I would make those changes. So 4 becomes 2 squared. And 1/2 becomes 2 to the -1. So what we have here is 2 to the power 2 to the power x equals to that. And then, of course, in this case, we can combine the exponents together. And then now we have the base is the same. Now we just equate the exponents. So therefore, 2x equals to -1, and x equals to -1/2. Cool. This one's tricky. All right. So you evaluated your first 6 logarithms. Remember, logarithms are just exponents. Now, I want you to notice something, example 3D and 3E though. These were questions in the form log base c to the power x. Okay. Notice the log and the exponentials are back to back here. Well, what happened in both of these cases? Well, the answers were 5 and 1/2. Well, where did the 5 and 1/2 come from? Yeah, that was the exponent on 3 to the power 5, and that's the exponent on the root 6. So it seems to be that if I have log base c of c to the power x, that just equals to the exponent, x. Why is this the case? Well, remember, logs and exponentials are inverse functions of each other. Remember, inverse functions are just like this, where I take something, squaring it, and I take the square root of it, I get back the same thing. That idea of inverse, where you do those two functions back to back, you get back the same thing. Well, guess what? If I take x and I raise it to the exponent, and I take the log of it, I get back the same thing, x. Now the question is, does this hold true the other way around? Well, let's find out. So, determine this. 3 to the power of log base 3 1,000. And I'm going to ask you to express this exponential as a logarithm. So let me just rewrite this first of all as an exponential with an x. Okay, so once again, this is the exponential form. So I'm now going to change this exponential form into logarithmic form. Okay, hope you remember how to do this. Remember the logarithmic form. log base. So what's the base here? Oh, the 3. Here's the base. Good. Base 3. And then we have the exponent. So what's the exponent on the other side? Well, the exponent is that log base 3 1,000. And then we have x, remember? So once again, base exponent number. Okay, so if we have something like this, I guess we've got the log pieces, we've got the base pieces. So I guess what's x equal to? Well, I guess x must equal to 1,000. So from here, by comparison, therefore I'll say 1,000 seems to be equal to the x. And since I was solving for x, yeah, it does look like it's true. So I think what I can say now for certain is if I have c, okay, constant, raised to the power of log base c with a number x, that also equals to x. So I'd like us to cloud or box these two things because they're important too. This one up here as well. Okay, those two things. Box those. Okay, whenever you have log and the exponential back to back, no matter what order, you just get back the same thing. Okay. All right. One last example, and we're done for this video. This is just part 1. You'll have part 2 in a moment, but I thought I'd break it up so that you don't have to watch too much at one time. Okay. Here I've given you a log, and I'm going to ask you to determine another log. It says convert into exponential form to help you out. Okay, so I guess that's a clue. So I'm going to ask you to take this and convert to exponential form. Remember exponential form? Base, which in this case is 3, yes, raised to the power, or the exponent, which is the number on the right-hand side, that's 2, and that equals to x. Okay, so x in this case is 3 squared. Oh, okay. Well then, after that, you have many ways you can do the next one. Okay. What do you think you can do? Some might be say, hey, why don't you just substitute x into there? Sure. So substitute x into the log base 381x expression. Sure. So we'll do that. And if you do it that way, it becomes log base 381, and x now becomes 3 squared. Well, that's just the number 9, right? So we'll write down 9. So then I guess you have to do 81 times 9. So 81 times 9, I believe, is just 729. And now you're faced with the task of evaluating this. So maybe now I'm going to ask you to change this now also into exponential form. So to evaluate, let's let this equal to, I don't know, y, and let's change into exponential form. And then we have here 3, which is the base, to the power of y, which is the exponent, equals 729. And then you have to figure out what 729 is. So 3 to the power of what? 729? 3 to the power of 5. That's 243. 3 to the power of 6. Oh, there you go. So that's the same thing as 3 to the power of 6. So y equals to 6. Done. Now you might be thinking, Mr. Lee, you left a whole bunch of space on the right-hand side. Why? Well, there's another way you can do it. Okay. So maybe method number 1 right now is to substitute like that. Maybe method number 2 here is what I'm going to ask you to do is actually change log base 381x into exponential form first. So if we do that, I'm going to let this, of course, equal to, let's say, y again, because that's what we're trying to solve for. So it'll be base 3 to the power of y equals to 81x. And notice I know that it's base 3, and I'm thinking maybe the 81 I should convert to a base 3 number. And most people will already know that that's 3 to the power of 4. Good. And then at this point, now I'm going to substitute for x. So I'm just doing it in different places in time, right? And in this case, x is the same thing as, we'll look up here, yeah, there's x. So that's now going to be 3 to the power of y equals 3 to the power of 4 times 3 to the power of 2. And when the bases are the same, you can just add the exponents together. So 3 to the power of y equals 3 to the power of 6. And lo and behold, y is equal to, you got it, 6. All right, so I hope you're feeling good about this. You need to memorize those things I put in the box on page 2. Understand that logarithms are just exponents, and you should be well on your way. See you later.